Have you ever wondered why the smallest particles in the universe behave so differently from everything we see in our daily lives? Well, welcome to the fascinating world of quantum physics, a realm where the rules of classical physics take a back seat. Quantum physics, in simple terms, is the study of the smallest particles in the universe and their interactions. It's about the tiny constituents that make up all matter, and it's here that things start to get a little quirky. Unlike the predictable world of classical physics, the quantum world thrives on probabilities and uncertainties. It's a place where particles can exist in multiple places at once and change their state just by being observed. It's a world that seems to defy logic, yet it's fundamental to our understanding of the universe. Quantum physics is not just important, it's essential. It's the key to unlocking mysteries, from the infinitesimal to the infinite. So, buckle up as we dive into the world of the very small and the very strange. In the quantum world, things can exist in multiple places at the same time. It sounds bizarre, doesn't it? But that's the reality of quantum physics. This concept is known as superposition. Consider a coin. In our everyday world, a coin can either be heads up or tails up, not both. However, in the quantum realm, before we look at it, the coin can be in a superposition of states, both heads and tails. It's only when we observe the coin, deciding to look at it, that it chooses to be either heads or tails. This brings us to one of the most famous thought experiments in quantum physics, Schrödinger's cat. In this experiment, a cat is placed in a sealed box with a radioactive substance that has a 50-50 chance of triggering a mechanism to release a lethal gas. According to classical physics, the cat is either alive or dead, depending on whether the substance decayed. But in quantum physics, the cat is both alive and dead in a superposition of states until someone opens the box to check. This thought experiment was proposed by Erwin Schrödinger, one of the pioneers of quantum physics, in 1935. It wasn't meant to be taken literally. Instead, Schrödinger wanted to highlight the strange implications of quantum theory. In the quantum world, reality is a game of chance. It's only when we measure or observe something that its state becomes certain. This principle, known as the observer effect, is a fundamental aspect of quantum physics. So, in the quantum realm, things can be in two places at once, or be in two states at once. They only decide their state when they are observed. This is what we mean by superposition. It's a concept that challenges our everyday understanding of reality. But it's also what makes quantum physics so fascinating and so fundamentally different from the physics we're used to. In other words, the act of observing affects the observed in the quantum world. Did you know that particles can be connected across vast distances? This is not a plot from a science fiction novel, but a real phenomenon in the quantum world called entanglement. Imagine having two coins, one in New York and the other in Paris. You flip the coin in New York and it lands on heads. Instantaneously, the coin in Paris also lands on heads. This is a simplistic analogy, but it captures the essence of quantum entanglement. Quantum entanglement is the process where two or more particles become intertwined in such a way that the state of one can instantly affect the state of the other, no matter the distance. These particles could be light years apart, and yet they remain connected. This is also known as non-locality. In the realm of quantum mechanics, local means that objects are only directly influenced by their immediate surroundings. Non-locality, on the other hand, breaks this rule. It suggests that an object can be influenced instantaneously by changes to another object, regardless of the distance separating them. Now you might be wondering, is this just a theoretical concept, or has it been proven? The answer is, it has been proven in numerous experiments. One of the most famous ones is the Bell's theorem experiment conducted in the late 20th century. This experiment showed that if the world obeys quantum mechanical laws, it must be non-local. This was a groundbreaking revelation that challenged our classical understanding of the universe. This phenomenon of entanglement and non-locality is one of the most mysterious and mind-boggling aspects of quantum physics. It challenges our everyday notions of reality and shakes the very foundation of our understanding of the physical world. It tells us that the universe is deeply interconnected in ways we're just beginning to comprehend. And here's the kicker. This instantaneous connection implies that these particles are communicating faster than the speed of light, something that Einstein's theory of relativity says is impossible. So, in a sense, these particles are communicating faster than the speed of light. Now, imagine if you could walk through walls. Sounds impossible, right? Not in the quantum world. Welcome to the curious reality of quantum tunneling. This is a phenomenon that challenges our common sense and shatters the rules of the classical world. Let's start by picturing a tiny particle, like an electron, approaching a barrier. In the classical world, the electron would need a certain amount of energy to overcome this barrier. If it doesn't have enough, it simply can't pass. The barrier is impenetrable. But in the quantum world, things are different. Our electron doesn't necessarily need the energy to overcome the barrier. Instead, it can just disappear from one side and reappear on the other. It tunnels through, hence the term quantum tunneling. Now you might be wondering, how is this possible? Well, the answer lies in the wave-like nature of quantum particles. You see, particles like our electron are not just particles, but also waves. This is known as wave-particle duality, another mind-bending facet of quantum mechanics. When the electron approaches the barrier, its wave function, which describes its state, doesn't stop abruptly at the barrier. Instead, it decreases exponentially, but never quite reaches zero. This means there's a small, but non-zero chance that the electron can be found on the other side of the barrier. And sometimes, that's exactly what happens. The electron, against all odds, tunnels through. It's as if it takes a shortcut through a dimension we can't see, bypassing the barrier entirely. Quantum tunneling is not just a theoretical concept, it's a very real phenomenon that's been observed and measured in the lab. It's even at the heart of many technologies we use today, like flash memory and scanning tunneling microscopes. So next time you hit a wall, remember our little electron. In the quantum world, barriers are not always what they seem. This is not fiction, but a very real phenomenon in the quantum world. You might be thinking, what's all this got to do with me? Well, more than you might realize. Quantum physics might seem like a far-off, abstract concept, something that doesn't have much relevance to your everyday life. But in fact, it's at the heart of many technologies we use daily. So let's delve into this a bit more. Take your smartphone, for instance. It's a marvel of modern technology, isn't it? But did you know that the very core of its functioning, the electronic chips, are a product of quantum physics? The semiconductors inside these chips operate based on quantum mechanics. Without understanding the quantum nature of electrons, we wouldn't be able to manipulate them to run our gadgets. Consider medical imaging technologies like MRI scanners, which provide doctors with detailed, non-invasive views into the human body. The technology relies on nuclear magnetic resonance, a quantum phenomenon. By understanding how atomic nuclei behave in magnetic fields, we have developed a tool that saves countless lives every day. And let's not forget about the hard drive in your computer. The technology that allows it to store vast amounts of information is based on a quantum effect known as spintronics. This involves manipulating the quantum spin of electrons to store and read data, but it doesn't stop there. Quantum physics also plays a role in developing new materials with amazing properties, understanding how biological systems work at a molecular level, and even helping us tackle the challenges of climate change. So, despite seeming distant and complicated, quantum physics is deeply interwoven into our daily lives. It's an integral part of the technologies we depend on. It's helping us push the boundaries of knowledge and innovation, and it's opening up new possibilities for the future. Quantum physics isn't just abstract science, it's all around us, shaping our world in ways we might not even realize. So, we've taken a whirlwind tour of the quantum world, a place where particles can be in two places at once, communicate faster than light, and even walk through walls. Let's take a moment to reflect on what we've learned. We've marveled at the concept of superposition, where particles exist in multiple states simultaneously until observed. We've explored the oddity of entanglement, a phenomenon where particles become intertwined, their states instantly affecting each other regardless of distance. We've delved into quantum tunneling, a process where particles, against all odds, pass through barriers they shouldn't be able to. We've also seen how these abstract concepts aren't just theoretical musings. They have real-world implications, impacting our daily lives in ways we might not even realize. From the technology we use to the fundamental understanding of our universe, quantum physics is deeply woven into the fabric of our existence. While quantum physics may seem strange and counterintuitive, it's a fascinating field that holds the key to understanding our universe at its most fundamental level.